So let us discuss concerning the derivation of Michaelis Menten equation, starting from the point of log and the key processes that states that the enzyme on the surfaces of the enzyme there are several cleaves. There are several cleaves on which substrates bind, to form enzyme substrate complex, under the reaction rate 1 reaction, while the backward reaction is under rate -1. Then from what enzyme substrate complex to form enzyme plus product, forward reaction is under rate 2, while the backward reaction is under rate -2. Backward reaction is under rate 2, and rate 1 is normally equal to constant 1 enzyme concentration times substrate concentration. That is forward reaction. The backward reaction is equal to rate -1, constant -1 enzyme substrate concentration, because the direction is starting from enzyme substrate concentration toward enzyme plus substrate, and the rate 2 is equal constant 2 enzyme substrate concentration rate 2, and arrow starting from the direction toward that direction, enzyme plus product, so is equal to enzyme substrate concentration, enzyme substrate concentration. Also, rate 1 plus rate 2, rate 1 plus this one negative rate 2. Also, rate 1 plus rate -2, rate 1 plus rate -2 is equal to rate -1 plus rate 2, rate -1 plus rate 2. So normally rate 1 plus rate -2 is equal to rate -1 plus rate 2. But according to certain assumption known as steady state assumption, according to certain assumption known as steady state assumption, we say that formation of enzyme substrate concentration is equal to the loss or disintegration of enzyme substrate concentration. It means that formation of enzyme substrate concentration through enzyme plus substrate to form enzyme substrate concentration, or enzyme substrate quite complex. This is equal to the disintegration or conversion of enzyme substrate concentration to form enzyme plus product, which diagrammatically can be represented as this form. So formation of enzyme substrate concentration through enzyme plus substrate to form enzyme substrate concentration. This is equal to loss of enzyme substrate concentration. The losing of enzyme substrate concentration or enzyme substrate complex normally lead to the formation of what enzyme plus product. So at the point here, this is the point of what steady state, the point of steady state assumption. Point of steady state assumption is constant. So normally this amount remain constant. This amount remained constant. If formation of enzyme substrate what concentration is equal to loss of enzyme substrate concentration, so it means that enzyme substrate enzyme what substrate concentration is equal to constant. So enzyme substrate concentration is equal to constant, is equal to constant, is equal to constant. Enzyme substrate concentration is equal to constant. So now from the above equation, now we can represent it as follows: enzyme plus substrate forward reaction under rate 1 and the backward reaction under rate -1. This is going to be enzyme substrate complex or enzyme substrate concentration. We are going to represent only by only forward reaction and not forward and backward reaction to form enzyme plus product. Why are we representing it? We are representing it according to this is theory or this assumption, steady state assumption, because enzymes remain not constant. The formation of enzyme substrate is equal to loss of, so it means that there's no any possibility of converting back. There's no any possibility of enzyme plus product to undergo reverse reaction or to undergo backward reaction. So it means that if it is impossible, totally what impossible to convert enzyme plus product to form enzyme substrate complex. It means that this rate 2 is going to be cancelled. It's going to be cancelled. That's why we have represented this on. We have represented here enzyme substrate concentration under only one arrow, no backward reaction. So we cancel rate 2, rate -2. Even here we're going to cancel rate -2. So we are going to remain with only rate 1 is going to be equal to rate -1 plus rate 2. Rate 1 is going to be rate 1 is going to be equal to rate -1 plus rate 2. Rate -1 plus rate 2. But we have to bear in our mind that rate 1 is equal to constant 1 is equal to constant 1 enzyme concentration, substrate concentration, and rate -1 is going to be constant -1 enzyme substrate concentration plus rate 2 is going to be constant 2 enzyme substrate concentration, Then from this point, let us see another equation concerning amount of enzyme. So we say that total enzyme concentration is equal to free enzyme concentration plus enzymes that have bound to substrate, or binding enzymes. So binding enzymes or enzymes that have bound to substrate plus what free enzymes is equal to total enzymes. So now let us make enzyme concentration the subject. So enzyme concentration here is going to be equal to total enzyme concentration. So once this close, this word close with the equal sign, it's going to be minus enzyme substrate concentration. Therefore, enzyme concentration is equal to total enzyme concentration minus enzyme substrate concentration. So from this equation, instead of writing enzyme concentration, we are going to fix this at this point. We're going to fix all these at this point, but before fixing um, from this equation, constant 1 enzyme concentration substrate concentration is equal to constant -1 enzyme substrate concentration plus constant 2 enzyme substrate concentration. Then here you divide by constant 1, divide by constant 1. So by dividing with constant 1, this is going to be constant 1 enzyme concentration substrate concentration divided by constant 1 is equal to constant -1 enzyme substrate concentration plus constant 2 enzyme substrate concentration also divide by constant 1. So constant 1 constant 1 is cancelled, remaining with what? Enzyme concentration substrate concentration equals to, if I take enzyme substrate complex outside, remaining with what? Constant 1 negative plus constant 2 divided by K1, then K1 negative plus constant 2 divided by constant 1. This is equal to Km. This is equal to Km. Therefore, enzyme concentration substrate concentration is equal to enzyme substrate concentration Km. But we have to bear in our mind that this E is equal to this one. So I'm going to fix this at here. So instead of writing E, I'm going to write all these total enzyme concentration minus total enzyme concentration minus enzyme substrate concentration is equal to enzyme substrate concentration Km. But no, let me cancel enzyme total enzyme concentration minus enzyme substrate concentration. This is equal to, should be on its own bracket, times substrate concentration times substrate concentration. This is equal to, it's going to be equal to enzyme substrate concentration Km, enzyme substrate concentration Km, enzyme substrate concentration Km. Then I'm going to fix it inside, substrate concentration inside, so it's going to be enzyme concentration, total enzyme concentration, substrate concentration plus enzyme substrate concentration. Substrate concentration is equal to enzyme substrate concentration plus enzyme substrate concentration Km. Then from there, enzyme total enzyme concentration substrate concentration is going to be equal to, I take this, so once this positive, close equal sign, once this positive, close equal sign, once this positive, close equal sign, once this positive, close equal sign. This is going to be, it's going to be enzyme substrate concentration Km plus enzyme substrate concentration S concentration. So enzyme total enzyme concentration substrate concentration, this is going to be, if I take S enzyme substrate concentration is going to be Km plus S, Km plus substrate concentration. So if I'm going to make enzyme substrate concentration, the subject now is going to be enzyme total enzyme concentration, substrate concentration over Km plus substrate concentration, Km plus substrate concentration. But we know V naught is equal to V max. V max also is equal to total enzyme concentration also is equal to enzyme substrate concentration. So long this is equal to V naught, then instead of writing enzyme substrate concentration, it's going to be V naught is equal to, and so long as total enzyme concentration is equal to V max, so in that kind of V max, we're going to write what V max substrate concentration. But also bear in mind Km is equal to substrate concentration. Km is equal to substrate concentration. So even here, instead of writing Km, we are going to write, instead of writing Km, we're going to write substrate concentration. So plus substrate concentration, which finally is going to be V naught is equal to V max substrate concentration over 2 substrate concentration. If you cancel this, if you cancel substrate concentration, we're going to remain with V naught is equal to a half V max, which is clear Michaelis Menten equation. Michaelis Menten equation, which is V naught is equal to a half V max. So thank you for listening. Make sure that you subscribe our video.